So hi everyone, students from second year BME, they are going to have a peer group learning activity on the topic MEG, that is magnetic encephalography. So in this peer group learning activity, the students going to explain what is MEG and what is the difference between MEG and KEG, and followed by they will be explaining what is the working principles and the application. So just have a look on this. Guys, shall we start the activity?
Yeah.
Yes, you can proceed.
So hi, today we are going to see peer group learning, where we are going to look about MEG and in full detail about it. So Swati, what is an MEG?
So MEG is standing for Magnetoencephalography, and it is an imaging technique which is used to detect abnormalities in brain activity.
So as it have magnetic, something is related to that or not?
Yeah, so as of magnetoencephalography, there is something related to magnetic field, which is whenever we think or write or read, there is electric synapse which is produced in our brain, which has a weaker current generated over it. And that current is also having a magnetic field which is induced, which is very minimal, less than the gravitational force. So this way, we take the magnetic flux, generate it as voltage, and we take the readings.
Okay, good. Then how can you differentiate EEG from MEG? In what way it is different?
So as of ma'am asked, what is the key difference between EEG and MEG? EEG stands for electrical signals, whereas MEG will take the magnetic fields. In EEG we get graphical representations of abnormalities in brain. In MEG we can get the anatomical pictorial representation of abnormalities in brain.
So Swati, according to your saying, does it Faraday law comes in here?
Yes, that was a good thing. Faraday's law is a very key important principle in MEG. According to Faraday's law, we know whenever there is a current induced, there is a proportional magnetic field and vice versa. So that is a key principle over in MEG.
It actually sounds interesting. Could you explain the working principle of this?
It is very simple. There is a sensor which is called as SQUID, which is a superconductance quantum interface device, and over 300 plus squids are placed non-invasively in the machine. And SQUID is very famous for collecting the data from a very minimal magnetic flux also. This way, even a small change in our anatomical structure would be implied on the graph.
So Swati, as you said, I think I have found few advantages of this. Maybe it could have high precision, and it is meant to detect the brain function, and it will be easy to use, as you said, the advantages over MEG and EEG. So this is what the advantages Swati?
Yes, high precision, and it is also used in different patients or different neurological disorders, which involve in autism, seizures, and many kind of neurological disorders. And also there is a case study which is related to MEG. There was a patient suffering from brain tumor, and it was near the speech affecting temporal region. The doctors were concerned about having loss of speech, but when they took MEG, there was 1 mm gap between the actual tumor and the speech affecting membrane. So successfully there was an operation done, and that way the patient was tumor free. So this way MEG is also used in various applications in medical instrumentation as well, and in different kind of neurological disorders. For explaining EEG and MEG, I have another difference. So for example, there is A, B, C. There is a connection between A and B, and there is a connection between A, B and C. But due to some external forces or any kind of internal perforations, there is a signal cut off between B and C. If it is in EEG, we get a graph which shows abnormalities. But whereas in MEG, we can accurately predict where the connections are being left out of the abnormalities. So in MEG, we will get the anatomical image where it says there is some problem between B and C. So this helps in easier predictions in medical systems.
Yes, you have given very good explanation about EEG and MEG. And can you explain even more better why EEG is predominantly used compared to MEG? In what case and what basis? And when and where we have to use EEG and MEG?
So EEG is like both are abnormalities in brain activity. In MEG, wherever we have brain tumors or diseases which cannot be predicted in EEG, we go for MEG. For MEG, we have a test analysis for the patient. For autism kids and all, we use MEG because they can't really get the concerns from doctor directly. So they have a MEG test, and if they qualify in that MEG test only, they are going to take over this device. So they have to sit for 30 minutes straight without any kind of movements. So for such patients, paralyzed patients and other patients who can't, go easily with the predictions in EEG, we move on to MEG.
That's very good. Yes, I hope so. You might have gained valuable insights about what is MEG and what is EEG. So both are equally important, and even though EEG is predominantly used, MEG has high very precision compared to the EEG. So when you want to locate any particular disorder, means then we have to go with MEG compared to the EEG. So I think I hope so you like this video. Thank you.